Now we move from individual Besu nodes to the design of the full network. Validators, bootnodes, RPC nodes, and observers each serve a different operational purpose, supporting consensus, discovery, access, and monitoring across development, testing, and production. Up to this point, you've seen where Besu fits, how public, private, and permission networks differ, and how Besu nodes reach agreement through IBFT or QBFT-style consensus. This module connects those ideas into a practical topology, choosing node roles, placing them appropriately, and preparing for permissioning, privacy, and enterprise design patterns. In Besu, topology is an architectural decision, not just a network diagram. It determines which nodes participate in consensus, which nodes serve applications, where trust boundaries sit, and how operational tools connect. A weak topology can overload critical nodes, expose admin interfaces, or create single points of failure. A strong one separates duties, controls access, and supports monitoring and audit needs. That is what turns a group of Besu nodes into a reliable enterprise network. All Besu nodes run the same client, but their role depends on configuration and placement. Validators propose and finalize blocks. Bootnodes make peer discovery reliable, especially during startup or recovery. RPC nodes provide application access, so their APIs need careful exposure and control. Observer nodes follow the chain for monitoring, analytics, or reporting without participating in validation. Separating these roles makes the network easier to secure, scale, and troubleshoot. Validator nodes are the trust engine of a permissioned Besu network. In IBFT 2.0 or QBFT, one validator proposes a block, and the others check it, vote, and finalize it once enough agreement is reached. Because validator keys can influence consensus, they should be protected like production signing keys. Keep validators away from public RPC traffic and unnecessary APIs. Place them across organizations and regions, so governance, resilience, and fault tolerance are part of the design. Validator design is also a governance decision. In production, resilience comes from diversity across owners, regions, networks, and infrastructure providers. Size the validator set for the consensus protocol, often using an odd number to avoid inefficient or fragile voting patterns. Treat validator rotation as a controlled change with approvals, key handling, and rollback plans. Then monitor continuously for missed blocks, peer connectivity, uptime, and participation. A permission network is only as trustworthy as the validator set behind it. Before a private Besu node can join the network, it needs a trusted starting point. Bootnodes provide that first contact. When a new or restarting node comes online, it asks bootnodes for peer information, then connects to validators, RPC nodes, and observers. Bootnodes are discovery infrastructure only. They do not need to validate blocks or expose APIs. In production, run more than one, so discovery does not become a single point of failure. For production networks, treat bootnodes as recovery infrastructure, not just startup helpers. Bring up multiple bootnodes first, spread across availability zones or infrastructure domains. Then start validators, followed by RPC and observer nodes, using documented bootnode or static peer settings so deployments are repeatable. Restrict access to authorized participants, and monitor whether each node is reachable, peered, and synced. If a node restarts or fails, this pattern gives it reliable paths back into the mesh. RPC nodes are the application access layer for the Besu network. Applications use APIs such as HTTP, WebSocket, or GraphQL to read state, submit signed transactions, estimate gas, and fetch logs or receipts. Keep this layer separate from validators so application traffic cannot threaten consensus performance. In production, place authentication, authorization, filtering, and rate limits in front of it. For higher demand, scale horizontally with multiple RPC nodes behind a load balancer. Every RPC endpoint should be treated as a controlled interface into the system. Start by reducing the surface area, disable unused APIs, and never expose admin or debug methods in production. Then restrict the path with private networking, firewalls, VPNs, allow lists, or service mesh policy. Put authentication, TLS, rate limits, and logging at the gateway where enforcement is consistent. Keep internal administrative access separate from external application traffic, so one compromise does not become full control. Reliable RPC access is an architecture decision, not just a node setting. Use multiple Besu RPC nodes behind a load balancer and separate read-heavy calls from transaction submission when traffic or risk justifies it. Repeated queries should come from caches or index data, so live nodes stay responsive. Monitor the signals that reveal stress early. Latency, errors, request volume, peer count, sync lag, and CPU, memory, and disk pressure. Observer nodes act as read-only witnesses to the network. They stay synchronized with the blockchain, but they do not vote, validate, or produce blocks. This makes them well-suited for dashboards, reporting pipelines, audit tools, and compliance review. Instead of sending heavy read traffic to validators, teams query observers. That protects validator performance and creates separation of duties. Consensus operators keep the chain running, while analytics and audit teams inspect the record safely. For analytics, the observer node is the safer data source. It collects blocks, transactions, logs, events, receipts, and state changes, then passes them into indexers, databases, search systems, or data lakes. Dashboards, BI tools, audit reports, and compliance checks should run from those downstream stores. This keeps expensive historical queries away from validator nodes while providing controlled retention, traceability, and reporting structures that raw RPC access usually cannot provide. Topology should match the purpose and risk of the environment. In development, keep it small. A few local nodes, simple RPC, and fast iteration. In testing or staging, separate validators, bootnodes, RPC nodes, and observers, so failures behave more like production. In production, design for zones, redundancy, hardened access, monitoring, and governance. The key is to evolve the topology over time, while testing production controls before launch. You've now seen how topology turns separate Besu nodes into an enterprise network. Validators protect consensus. Boot nodes keep discovery and recovery dependable. RPC nodes serve applications without exposing validators. Observer nodes provide visibility and audit support. Next, we'll build on this foundation with permissioning, privacy, and enterprise design patterns.